The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Alan Schimmel, Editor-in-Chief, DevOps.com, and we're here for another DevOps webinar. Got a really great webinar in store for today. For our listeners and attendees who are interested in Docker, CoreOS, containerization, developing SaaS applications, and so forth, this should be right in your sweet spot. Today's webinar is actually how to use the TICK stack, CoreOS, and Docker to make your SaaS offering better. It's brought to us by InfluxData. They're sponsoring today's webinar. And before we get into it, though, I just want to take a quick moment. For those of you who are new to our GoToWebinar control panel or haven't listened to a DevOps.com webinar before, we do things just a little differently. We love questions from the audience, and what we highly recommend is that you use the question section of your GoToWebinar control panel, which for most of you will be on the right side of your screen. And if you can hit the little caret or arrow next to questions, it'll expand. We're going to ask that as questions pop into your mind, and feel free, ask as many as you'd like, if you could type them in real time into this section. We have set aside time for questions at the various points in today's webinar, but if you're like me, by the time we ask the question, you may forget what you want to ask. So please type it in real time when it pops in your head. This way it's queued, it's in there, we'll get to them in order, and you don't have to worry about remembering them. In addition to the question section, there's also a chat section down at the bottom of your control panel. In our webinars, we use the chat section if you're having some sort of technical problem. We do have webinar engineers standing by to help, and maybe your audio's not working, or your the slides are not advancing, or something like that. If you could type it in there, we can try to get some help to you and get it fixed as quickly as possible. It's our intention, that these webinars go off without a hitch, but sometimes things happen, and if you let us know, we'll try to help you. So with questions out of the way, chat out of the way, let us jump into today's webinar. As I mentioned, it's how to use the TICK stack, CoreOS, and Docker to make your SaaS offering better, and it is sponsored by InfluxData. And if we can go to our next slide, let me introduce you to our main speaker today. Very lucky to have joining us from Italy, Gianluca Arbizano. Did I mess that up too bad, Gianluca?
No, it's okay. Thank you.
Great. And you can see in his About Me, Gianluca is obviously someone, besides growing fruit and vegetables, is also a major Docker user and big supporter and user of open source as well. So with that being said, let me turn things over to Gianluca. And we're here if you have any questions. And please do use the questions section. Gianluca, it's all yours.
Thank you for this presentation. And as you said, I'm Gianluca. I work as a site reliability engineer in InfluxData. And my daily work is to build and release what our customers are using to provide cloud and to use our database and our TICK stack manageable by us and not from them. The agenda looks like this. I'm going to speak about what is InfluxCloud and how did we build it in this way, and what we learned from this experience, and how we are making monitoring, because as you probably know, InfluxData is the company that is working on InfluxDB and time series database, and we are providing a full solution to monitor your servers and your infrastructure, but it's also something that a lot of companies are using to manage IoT and sensors. But today we are going to stay focused about our cloud infrastructure and how we are trying to make it better every day. The company InfluxData founded in 2013 and is delivered an open platform for metrics and time series database. We have different tools that all of them are open source. Probably the most famous one is the InfluxDB, that is the time series database, but we also are building around it other tools that are helping customers and developers to build analytics and metrics platform. One of them is called Telegraph, that is the agent that you can install in all your servers, and you can configure it properly to take different kind of input and send them to InfluxDB or other time series database. As I said, everything is open source and we are not locked into InfluxDB. In this case, Telegraph works with different kind of output. Our main values in InfluxData are developer happiness, and we are trying to keep developer happy, and we are trying to make tools that scales and really well and that are really easy to use for developer and for also who's building it. Well, time is another big value, not just because we are using and managing time every day, but because it's like an important part in our life. And time to value means that we also are trying to build the most valuable things, and it doesn't matter always how much time it requires. At the moment we have 70,000 active servers that are using InfluxDB, more than 10,000 GitHub stars, and 300 customers in cloud and enterprise, because we are offering two kind of solution. One is the cloud one, and we have an application and you can ask them to provide full clusters, or we can give you an enterprise binary with license and all the things like that, and you can manage it by yourself. Why we decided to build a cloud infrastructure to ship InfluxDB and all our stack? In first, because to offer a time series database as a service. InfluxDB is growing really fast, and we are happy to make it really easy to use. And we know that as an open source tool, a lot of companies and a lot of developers are free to download it and run it in them infrastructure without need to ask anything to us. But we also know that the as a service model is a good service that other kind of companies can be happy to use. We was also looking to build a use case for InfluxDB. We are using InfluxDB to build the cloud platform. It means that for us is a good way to test new release or to understand how it works in a production scale. All the tools that we are building now are ready to go in production, and we are happy to have a production use case that we are able to control. It was also a good way to make money, or at least something to try. And monitoring is also a perfect third-party service. We know what third-party services means, and there is a lot of as a service tool. Like there are tools that are helping you to build login and logout, or to ship email, or to store pretty much everything you need. Time series and monitoring is a good use case, because when your infrastructure is down, your monitoring system needs to stay up, because it needs to notify you that you're down. And if your monitoring system is down with your infrastructure, there is something that is not working well and can cause really big problem. And that's why have a third-party company that is managing your monitoring system can be a good solution for companies that are not able to maintain a monitoring system, how to have different teams. And if you are not doing monitoring, it's not your core business, why you need to put yourself in this kind of trouble. And that's why we decided to go with InfluxCloud. This is the high-level architecture. We have the subscriber request that is asking for a new cluster. We have an application that we call InfluxCloud that take the request and tries to deploy the cluster on AWS. We are supporting different regions, and every cluster is isolated, and there is no way to communicate out of the cluster. We have different concepts. The cluster itself is InfluxDB. The InfluxDB that we share in cloud provide the sharding feature that is not something that is in the open source tool. It means that our cluster is able to scale in a horizontal way and not just in a vertical way. The cluster is the combination between InfluxDB data nodes and InfluxDB meta nodes. We can also create for you add-ons like Grafana or Capacitor or Chronograph in the new version. In this way, you are able to have all the stack provided. As I said before, we have different projects. Telegraph is one, as I said. We have another one that's called Chronograph, and it's a visualization dashboard that we are using to manage all the tick stack. It means that it's not just for create dashboard, but you can also manage your InfluxDB database and your Capacitor instance. Capacitor is the tool that we built for two main reasons. One is for alerting, because we know that you can store all the data that you need, but if you are not able to manipulate them and make it useful, that's a big limitation. And that's why we built Capacitor that support different output and different alert like PagerDuty or SMS, ERC, Slack. You can write tick script that are listening on InfluxDB data and are taking decisions based on what happened on the behavior of this data. Another feature that Capacitor provides is the downsampling of the time series. If you think about how many time you are asking CPU in all your servers, you can imagine that you are taking a lot of data and you are storing a lot of data in InfluxDB. Sometimes you don't need all the data, or you need data for a couple of times, and after sometimes you need to make it simple, maybe have a different granularity, and you need to clean your database, and Capacitor is able to listen on a stream or listen on a batch of data and format your data in a different way or store them in another InfluxDB instances. But I'm going to show you how we use Capacitor later. What is important to know from this slide is that we are using AWS, we support different regions, and we have a customer that is asking for a new cluster. This cluster is usually something like, I'm happy to have a cluster that is a T3, T2 medium or T2X large. We are not using this nomenclature. We have the different nomenclature, but I think that this is easy to understand. And I need a cluster with 3 data nodes and 6 meta nodes or something like this. I need a new service, a new add-on, a new Grafana, and all these requests are taken care by the InfluxCloud application, and it's making the cluster on AWS. Some points that we try to achieve with InfluxCloud is the velocity to deploy a cluster. You probably know, if you work with AWS, that some sites and some procedures are not always really fast. Create some kind of EC2 can be really expensive. If you think about resizing disk, can be an action that usually requires a lot of time. Always depend of how much gigabytes you are trying to resize, but it's something that can work for a lot of time. All the machines need to be able to communicate what they are, and for example, if they are data node or meta node, or there is a Grafana inside on Capacitor, they need to communicate in which cluster they are, and they need to communicate the state of itself, like if they are up or down, or if the service is working as expected, or there is something that is not working. All the clusters need to be restarted easier. We don't need to log in AWS and click around. The idea is to have a really simple interface to communicate with clusters. And we need a really simple interface because we have a support team that is helping customers every day, 24 hours a day, to make the system alive. And we need to build something that the support team is confident and happy to use, and they are not scared to use our tools. That's one of the goals that we have. This is another corner of the InfluxDB architecture. The InfluxCloud is split in different services. We have a front end that is in Ruby. We have a back end in Go, and we have an Influx agent that is also in Go. The new version of the front end will be in JavaScript, and but at the moment it's in Ruby. We are communicating with the backend via JSON API. We are using Swagger to build the interface between the backend and the front end. And for the internal communication between the backend and the Influx agent, we are using gRPC. That is a binary protocol provided by Google that now it's hosted by the Cloud Native Foundation. And like the backend is the brain that is taking care of the request and is creating the cluster on AWS. Every cluster, every server in the cluster is running an Influx agent that is a binary that is wrapping, like it's making different things, but the main one is it's wrapping and exposing a simple interface to Docker socket. Because as I said before, we need to keep stuff simple, and we are happy to expose only the feature that we need to use and not all the Docker socket or all the Docker capabilities. And that's why we have an Influx agent that is wrapping, and is wrapping Docker API, and it's running in all the servers in all clusters. If we go deeper inside a specific cluster, the architecture and the topology looks like this. We have, as I said, different, when you create a cluster, you always have data nodes that are storing all the data. All your time series are stored in this example. There are 3 data nodes, the 3D that you can see in the image. But we also have meta nodes, and the meta nodes are storing information about where the shard and where your data are, because we need to keep tracking or on where we store them. We also deploy add-ons. As I said, in this example we have Capacitor. It means that our customers have to have not just InfluxDB but also Capacitor. We are locking all the traffic and all the communication inside the cluster and outside the cluster with security groups. It means that every cluster has a security group, and based on which service and which add-on you have different configuration, and you are able to, and we expose different stuff. The important thing is that everything that we expose to the external world is exposed via ELB. It means that we are not exposing Capacitor in InfluxDB. We always have another layer, an elastic load balancer at the moment, that take care about SSL certificate, because we provide everything under SSL and things like that. This is how it looks in practice. Let's go deeper to the last piece of code that we need to cover is the Influx agent. As I said, the main feature is expose Docker capabilities in a restricted way and in a safer way, and in a way that we are able and happy to control and use. Every server in the cluster is running different kind of containers, but there are some of them that are shared or that are the same. For example, we are using external service to collect all our logs, and we have an agent that is running on Docker that is taking on the logs that we need and it's shipping them. We use SkyDNS to keep track of our internal DNS configuration. It means that there is a SkyDNS agent that is running in every cluster, and all these containers are managed by the Influx agent. There is also one telegraph for every server because we are using our stack to monitoring our cloud service. It means that based on which service is running in the server itself, Telegraph is well configured to take all the information that it needs to take, and it ships them to our centralized monitoring system that I'm going to show you how it works later. And obviously, there are some containers that are running only in some servers. For example, InfluxDB is running only in the cluster servers. We also ship Capacitor that runs in different container and things like that. All these containers and the order that we need to start this container by the Influx agent. How we are making provisioning of these boxes? We are using CoreOS, and it means that we have a operating system designed to ship containers, to run containers, and it's optimized to do that. We are also using really a lot the cloud init file. This is something really interesting because in my previous experience, I always saw a company that was try to make things really complicated using deploy as a code, or all the tools like Chef and Ansible and SoulStack. What we are doing here is we are intensively using the cloud init function. If you don't know what it is, a lot of cloud providers supporting it, and it's a kind of specification that runs every time that you start a new servers. And you can configure networking users, you can configure, you can run bash script. And what we are doing is pretty much, we are doing everything via cloud init, because we just need to configure the servers with the proper users, and we need to start the InfluxDB, the Influx agent. The Influx agent is going to communicate with the backend. It's taking information that it needs. Usually it takes information like what I need to run, who I am, and which cluster I'm running, and things like that. When the Influx agent takes this information, it's able to spin up containers, and it's also taking care about the availability of all the service. Why CoreOS? We keep CoreOS because, as I said before, it's designed to deploy containers. It means that it has some better capabilities and security feature, like the permission, the folders are designed to work well with containers. And we go to containers because we was looking for a way to ship InfluxDB in a safe way and in an atomic way. And for us, containers at the moment is the best solution because we have all our images pre-built and we just ship them in the new clusters. CoreOS has also the how to update features, and when we started, we thought that this was a really great capability for us because it keeps the maintenance really low, because all the security patch and are applied by CoreOS automatically. But to be honest, after some times we realized that was not what we was looking for. And if you think about what we are shipping, we are not shipping a front end. We cannot stay offline, take your database offline for a long time. And every time that CoreOS applies a security patch, it needs to restart a server. It means that we saw some strange behavior like unattempted restart. And it's something that we need to control, and we are happy to control. And that's why we started with a auto-update feature enabled, but at the moment it's disabled and we are managing patching by ourselves. Probably if you are working with CoreOS and you are shipping a different kind of service, you can keep the auto-update on. In our case, that was not working well. We still need to find a good way to use it. And another good reason to use CoreOS is for the flexibility that it provides. If you think about this, CoreOS already has an etcd cluster that is an etcd instance that is running, and we are using that etcd instance to store all the information of the clusters, of the state of the cluster, and etcd is really easy to scale, and like it comes from with CoreOS, and at the moment we are working really well with all the etcd API and the client. How we are monitoring our stack? We have this two kind of monitoring system. One is for logs and one is for time series. Obviously, for time series we are using InfluxDB, and for logs we are using an external service that we take all the logs with an agent, as I said before, and we get them back to paper trail in order to allow ourselves and the support team to understand what's going on in the server, in the clusters. And every server has a telegraph agent that is getting all the information. We are taking system information like CPU, memory, IOS, all the networking information that we can take out of the server. We are also monitoring etcd, because etcd exposes a Prometheus-like entry point, and we are taking information from that entry point. For every service that is running in the node, we are taking all the information that we can. We are always using telegraph. It means that our architecture is really easy. We send every time series data that we take from the node to telegraph. Telegraph collects them for 10 seconds, and we send a bunch of data to InfluxDB. This helps us to have a better, it's an optimization in terms of networking, because if we are going to send point-to-point communication to InfluxDB, the networking traffic is going to grow a lot, and we really don't need this kind of stuff. We need to just have a monitoring system, and we decided to go for this kind of solution. As I said, we are taking all the projects that we are building are exposing metrics, and we use Capacitor we use Telegraph to take them and ship them to InfluxDB. Another important things that we are building is dashboard. We are currently using Grafana to manage our monitoring, and we have a lot of dashboards. Some of them are really complex. As you can see in the list, we have more than one dashboard to have different vision of a specific cluster. We split dashboard based on service. For example, you can see that we have an InfluxDB Docker that is monitoring all the Docker related things. We also have a paper trail events. It means that we are monitoring how paper trail is the third-party service that we are using for logs. We use regex to listen on some events, and we are storing them events and we are visualizing them events to Grafana. We also have another interested dashboard is the cluster comparison, that we can give to them different cluster, and it's able to create comparison graph between different clients. And this helps us to understand how a normal cluster is behave compared with another cluster that maybe is having problem. Another tool that I mentioned before is Capacitor, and we are using it for alerting. You can see some of the tech stack that we are using. We are listening on the disk usage, and we are sending an alert when something went wrong. And if the disk is full, before the disk is full, we are sending an alert in order to understand what's going on, and in some case, makes an action. InfluxDB has an internal queue that is buffering data, and we are also managing how is long that buffer in order to understand if something is going on. Maybe the customer is sending a lot of more data, and we need to notify him that he's growing too much for the plan that he's paying for. And we also are monitoring the HTTP requests that we are handling on the InfluxDB API and other alerts. We are also using Capacitor to build statistic. As I said before, it supports different kind of output. We are using PagerDuty for alerting, but we are also using InfluxDB as output in order to get stats. For example, the hot shard tick. I don't know how many of you know how InfluxDB works, but in a really high level, InfluxDB is grouping data in shard, and these shards are containing a bunch of data, and the hot shard is measuring how many reading and writing actions we are hitting in a specific cluster. And what the host shard is doing, is storing an event when a shard is working a lot. In this way, we can have stats based on cluster ID and on customers to understand how they are behave in our cluster, in our cloud. And another point that we are trying to achieve is the automation and continuous delivery everywhere it's possible. I'm not speaking about the version of InfluxDB that we ship in the cloud. I'm speaking about all the related services and tools that we build for clouds. We have some Docker images that we need to keep updated. We have all the tech stack that I showed you are deployed automatically in production. It means that we are able to manage them as a normal Git repository. This slide is the Circle CI configuration that we are currently using in InfluxDB, and that's the idea. We are trying to make all the things that are repeatable automatic, because I think that, like as I shared before, one of the value is time to value, and if we lose our time making repetitive tasks that a server can do for us, we are not really making value for us and for our customers. That's why automation keeps a really important step in my work. Don't trust anyone, monitor your monitor. As I said, we have a centralized place that we use to store all the information and all the metrics that we are taking from our cloud service, and we are using them to alert customers, to alert ourselves, to build nice dashboard, but we don't trust ourselves, and we need to be sure that we are good enough to achieve all the requests that our cloud is making, and we are monitoring our monitoring system. And this is part of the dashboard, and that I screenshot yesterday. And yeah, that's another important thing that you need to know when you build a SaaS application. You need to be comfortable with it. You need to be happy to work with it, because if you do something that you are not happy to work with, or you are uncomfortable to update, you are going to have trouble and cause trouble at some point. And take time to think about how to implement a new feature, or also take care about all the tooling that you are writing. If you are already providing a SaaS application, you know that you are building, you are also building not just the SaaS application itself, but you are building thousands of tools that the support team is using, the marketing team is using to show your product, the other developers are using to deploy your infrastructure. All these tools need to be updated, need to be well done. A bash script that is not under Git or version control, if you are just using that bash script, maybe you are doing something bad. Share what you're doing, share all the bash script that you have in your laptop, because some other in your company can use them, but can also make it better. Now, a bullet point of what we learned in our experience running InfluxDB on cloud. If you see the abstract, we are currently running more than 1,000 instances in AWS. It's a good number. It's a good challenge, and as I said before, we are trying to support our security, our support team in the best way, and that's why we are building tools that are making them out to AWS, that are making myself out of the AWS console, not because the AWS console is bad, but because if you don't configure the right role, or if you are making people if you're making them able to do anything they can do on AWS, you are going to have trouble at some point. You need to take a path and design a tool that is running on that path. And that's why we are designing applications that are helping us to follow a path, to improve security, to improve control, and to have less human error. We are also using monitoring to identify repetitive support tasks or repetitive tasks that I'm doing as a developer. It means that if I'm restarting the same cluster, or I'm receiving a request from a customer to resize disk every 3 weeks, maybe I can try to predict what's happening with all the metrics that I get, and maybe be proactive on what I'm taking. All the data that you are taking from your application are not just really powerful to see and really good to see. I'm in love with when I see a lot of graphs and a lot of lines going on. I know what I mean. But if we can use the data to build something smart on top of it, we are going to save time and build a better experience for our customers. And that's what we are trying to do with our monitoring system and with the tools that we provide. What we learned is that people need visibility on their cloud service. If you know how InfluxCloud works now, you can see that it's really, really simple. You log in, you register your username, you put your credit cards, you decide which size of cluster you need, and you get back a URL, and you use that URL to log in Influx. That's really great, because it means that tomorrow, if you need to go out and manage your InfluxDB by yourself, you can do that, because it's a URL. You just need to back up your data and start to take care about your InfluxDB. But what we also learned is that our customers are happy to see what's going on in them clusters, also if it's managed by us, because they maybe have some bad journey in their application and they are happy to know if InfluxDB is like not helping or it's in trouble. And we are happy to give them this information in order to make our support team doing something more interested, and also to give people, to build trust with people. And another reason is because our customers are really smart and they can help us improve our monitoring system. How we monitor their cluster, we get a lot of feedbacks from them, and we think that have a sort of co-monitoring platform can be something really good. We also learned that metrics are everywhere and they are like really different from what you imagine. Maybe you are building an application and after some times, maybe because you have a strange bug, you will discover that metrics that you never thought that it will exist, it's really useful and you can track that metrics and have a better understanding of your application. We did something similar with the alerting system. We are managing a lot of alerts from InfluxCloud. Some of them are like problems that we need to solve. Some of them are just notification. But the number and the type of alerts that we get is also a really good metrics to understand the state of the InfluxCloud or the state of the cluster. And in practice, we are building alerts on alerts at some point. And that's something that, like, when we discovered that we was like doing something like this, it was a funny time, and maybe can be useful for someone else. As I said before, we are also trying to achieve proactive monitoring and proactive automation. We are building tools. We are trying to build tools that can use our metrics to understand what's going on, and maybe when we know what's going on, we can also build automation on top of it. That's the main goal that we have and we are working on. What we are doing now, because as you can see yourself, we have InfluxCloud and we have 300 customers that are using it, but we are making it better every day. And right now we are working on some really big features that we are going to ship soon. One of them, as I said, is the co-monitoring between InfluxData and customers. And we learned that we need to give them all the visibility that they need. And we have this visibility because we are already monitoring clusters. What we are doing is we are building an architecture to share that data with them. I'm going to explain it later after this slide. Another big feature is we are having chronograph as add-ons in our cloud platform, and we are also starting a new combination. When you start a new cluster, you get for free chronograph and capacitor in order to allow you to enjoy all the stack that we are building. Yeah, welcome to the T-stack in cloud, because before we was not shipping chronograph and the capacitor was an add-on. Now we are shipping them together. We will ship them together. The support team need to grow with the application, with the platform. We are doing a lot of change, and the goal is to make our cloud bigger, but we cannot do that without good support tools and good support people that can help customers to use our tools. And to do that, it means, from my point of view, that I need to build a better set of tools. I need to have more visibility on the state of cluster in order to put support team and customers in control of the cluster itself. Another goal that we are trying to achieve is to glue all the API that we are building and we are using. I told you that we are using Docker, we are using etcd, we are using Papertrade, we are using CoreOS, and all of these modern applications are saving API. We are building InfluxDB, we are building Capacitor, and they also provide API. It means that we can take all these API and we can try to glue them together to have a really good user experience for customers and for ourselves. That's what I don't really like when I get an API, a service that provides an API, and I just use the API as the documentation says. You need to take the API, you need to understand what you are trying to do, and you need to match them together to build something good. That's the idea that we are following. This is a really simple and lovely graph about the co-monitoring. As I said before, we are shipping chronograph with the new clusters. We will ship chronograph with the new clusters. It means that we can have a new source and you can have a dashboard that show what we see from our side about your clusters. And that's how we are going to build it. We have InfluxCloud, we have our internal monitoring that is taking all the information from all the agents that are running InfluxCloud. We are going to run a Capacitor tools and with some tick script that are able to listen on all the points that we are taking in the internal monitoring, and the Capacitor will be able to join some data together, format them in a more light way, and ship them in another InfluxDB instance that you are going to see in a Grafana dashboard, in a chronograph dashboard. That's the main idea. In this way, we are going to use our stack and, in this case, Capacitor to manipulate a lot of metrics and serve them to you. In conclusion, that's what we are doing, that's what we did and why we did that in this way. Obviously, as I show you in the what we learned, there are a lot of stuff that we was not aware, probably one of them is the CoreOS out update that caused us some trouble, but it's part of the challenge. We understood how CoreOS works and how they build that feature in this way, and we are happy to I think that one of the best feature that we have with all the tools that we with all the architecture and all the tools that we design and took is the flexibility. All of them are serving API. We control a lot of them, and we are able to, as I said before, collect them together, glue them together, and provide a really good user experience. If you need to know more about InfluxDB and InfluxData, you can visit InfluxData.com. There are documentation about our tools, and there are information about the InfluxCloud and Influx Enterprise. You can download the tick stack. There is really nice tools in GitHub that you can use. It's called Sandbox, and you can start the tick stack in a very, very powerful and easy way. If you have any questions, or if you are happy to, if you're like a community man as I am, and you're happy to be in contact with the InfluxDB community, we have a community.influxdata.com site, and you can post questions or help other people to use the tick stack better. Thank you.
Giancarlo, thank you. That was a pretty in-depth look there at what we've got going on with Influx and how it works with Docker and CoreOS and so forth. We don't have a lot of time for questions, but we do have some. And Terry Smith asked a good question earlier on, and that is, will you be supporting other public clouds such as Microsoft's Azure?
At the moment, like we are using AWS, and it's going to be the unique one. But for our customer, it's not really important which cloud provider we are using, because they are just getting the InfluxDB, Capacitor, chronograph URL, and all the pricing is glued together by InfluxData. Like InfluxDB itself works in every service, in every environment, but from an InfluxCloud point of view, we are continuing to using
Got it.
AWS, sorry.
Okay. Our next question. So Giancarlo, obviously Kubernetes is InfluxData is kind of standardized on it. But what about for those who aren't standardized on Kubernetes?
Yeah, like, yeah.
Say they're using Docker Swarm or Docker Enterprise or something like that.
Yeah, we decided to build our scheduler. The backend that I showed before, you can see it as the scheduler. If you think about the Kubernetes Azure application, because it's the application that is contains information about where the containers need to go, which containers we need to start, and stuff like that. We decided to go for some custom implementation, because we need to control them in any point, in any little line of code. We need to be able to make it better and to build support tools that our support are happy to use. Another point is that when we started to build InfluxCloud, the support team was not really confident with Docker, and for us it was a really big challenge, had not just Docker, but also Kubernetes, or only Kubernetes, because at that point only Kubernetes was available. And we decided to go for something simple that we are able to improve in all the parts.
Okay. We got one other one here from Karen. So Giancarlo, people want to know, what are those .tick files and how are you using these?
Yeah, the tick scripts are DSL that you can write, and they work in two main different ways. You can write query, and in this way you are using the kind of batch feature. You can say, take all the time series, all the CPU usage metrics from the last half an hour and do something with them. You can compare them with mathematical function, like if the CPU usage is more than 70%, send me an alert because there is something that is not working. Capacitor supports different kind of alert, as I said, output I said before. Some of them are really hard to manipulate, like it supports Slack, but with Slack you can just say Slack message on a channel. It also supports more flexible alerts, like post. You can send a HTTP post if something is not going well, and from that you can do proactive action on your metrics.
Got it. And by the way, Karen, who asked that question, said thank you. I don't see any other questions, and we are just about out of time. So first of all, Giancarlo, let me thank you again for doing a great job in the presentation here today. For those out there, it's not easy to do one of these solo by yourself and fill an hour in just monologue without back and forth. So fantastic job. Thank you very much to InfluxData for sponsoring today's webinar and allowing us a peek into the functionality here. And most of all, thank you all to everyone who came in through the course of the webinar to listen. And for those who are interested, this was recorded. Slides, recordings will be available within 24 hours on DevOps.com and on DevOps TV, our YouTube channel. So if that's it, everyone, have a great day. This is Alan Schimmel for DevOps.com, and we'll see you soon on another webinar.